Welcome. In this video, we'll be talking about the polarity of bonds and their effects on solubility. Now, to give you guys a jumping off point, when we talk about polarity, it's just a way of saying that the greater the electronegativity difference between the atoms in a bond, the more polar the bond will be. As we know that when two molecules approach each other, they will either attract or repel. This is the idea known as a compound's intermolecular force. So as you can see here, we see the positive will attract the negative, and the negative will repel the negative, just as the positive would repel a positive. Now, the three major types of attractive forces that cause molecules to associate or disassociate are London dispersion forces, which affect all molecules, dipole forces of polar bonds, and hydrogen bonds that link molecules having an OH or an NH group. Now, London dispersion forces are just a temporary dipole moment in a molecule that can induce another temporary dipole moment in another nearby molecule. Basically, what that means is that the London dispersion forces are the main forces you will see in nonpolar molecules. So when you have a positive and a negative, they will attract each other just temporarily. Some good rules to remember about London dispersion forces are that the larger the atoms are, the more polarizable they are. And branching will lower the boiling point because of the decreased surface contact between the molecules. Dipole-dipole moments are usually seen permanently as a result of a molecule's polar bonds. In a dipole moment, the most stable arrangement has the positive end on one dipole close to the negative end of another. As you can see here, just like we said, positive of one end will be right next to the negative of another end. Dipole-dipole forces are the results of attraction between positive and negative ends of the dipole moment in a polar molecule, as we see here. Since these forces are stronger than seen in London dispersion, this attraction has to be overcome when the liquid disassociates, typically resulting in a larger heat or a larger boiling point. For hydrogen bonding, you can think of it as a particularly strong dipole-dipole interaction. Hydrogen bonds are referred to seeing hydrogen bonding with oxygen, nitrogen, or fluorine. Hydrogen bonding has the large effect on the physical properties of an organic compound. As you can see, just like we said, it's going to be forming with an oxygen, or you can see it with a nitrogen. That's really all it means with that. As far as the polarity goes that we see, just like I said before, just think of it as a difference in electronegativity. So when you have a positive end on one side and a negative end on the other, so as you can see with the arrow here, the arrow will always be going towards the most electronegative atom. So just like we see here, you're going to have this one go towards the nitrogen, just as you would normally see them go just like this as well. That's all that means. So as I said before, hydrogen bonding comes when hydrogen is paired with a nitrogen, oxygen, or fluorine. I hope this video helped clear up your understanding of polarity. You can get an A in OChem, and we're here to help. Thank you for watching, and we'll see you next time.